do is we're going to take a look at y is equal to -4 of 0.5x minus 1. We're going to try and graph this function, and then what we're going to do is we're going to check it on decimals. So here's what we're going to do. We're going to take a look at our original function. We look at the function, it is a sine function, so we're going to do this in red, in black. So we're going to start with y is equal to sine of x. Now, what I want you to do is I want you to immediately only draw one period of sine x, and you know that sine x actually runs for 360 degrees. It starts at 0, it ends at 0, and exactly halfway between it is at 0. Then we go between the 0 and the 180 to figure out where it is now. For sine at 90, we get 1, so it's above the x-axis. And then when we hit 270, the only place where it's going to go below is at -270. So I'm going to put a dot there. The very next thing that we're going to do is we're going to go and draw our sine function, our basic sine function. There we go, and we are perfect. The next thing that we have to do is we have to take a look at the next equation for our graph. Now, I always deal with the stretches and the compressions of the curve. Now, the easiest thing that we can do immediately is we can go and work on the vertical stretch of our graph. Now, the vertical stretch of our graph is based on the amplitude, which is right here. So we're going to write y is equal to 4 sine of x to be our next progression in the graph. Now, having that progression means we still have all the same points except all of the y values have been stretched to a value of 4. So 0 times 4 is still 0 here. 1 times 4 gives us positive 4. And then this one here. -1 times 4 gives us -4, which gives us a point way down here. And our zeros are still 0. So when we draw this is going to be very difficult for me. It should be difficult for you as well, but you would graph your sine curve to the sine curve like this. So that is what y is equal to 4 sine x is. The next thing we have to take a look at is this part here. Or we can avoid that and immediately take a look at the minus sign. The minus sign of this graph goes and flips my graph. So I'm going to write the equation y is equal to -4 sine of x. By doing so, all of these points that we have here are going to flip. Now, by doing so, what we've just done is all we've really done is we've switched we've actually flipped all of our y values to the negative. So positive 4 becomes -4, 0 still stays 0 for each of the zeros on the red graph. But then any negatives become positive, and any positives become negative. And so we have this blue curve as a result. The next thing that we have to look at is this portion here. So now that we have dealt with the stretch vertically and horizontally for our graph, vertically for our graph, we have to take a look at the horizontal stretch. So the 0.5 basically gives us an idea of what's about to happen. What we have to do is we have to do a calculation. We know that the period is equal to 360 divided by the b value, which is in this case 0.5. So we get 360 divided by 0.5. That means our new period is equal to 720. So now all we're going to do is we're going to take all those points that we have for our red graph, and we're going to move them out to a length of 720. Basically, we're just multiplying every x value by a factor of 2. So if you think about it, we have our endpoint here. We're taking a look at our at our blue. And our middle point is now going to be at 360. Our next point is going to be at 0. Now, we should also make sure that we kind of basically group this, because we're going to use it later. I'm just going to shrink this and kind of put it off to the side here. And we'll take a look at where that goes later. Put that up here. So that green stuff goes for P in order to figure out the new period of our graph. Now, in essence, we've taken our period and gone from 360 to 270. So all the x values are being multiplied literally by a factor of 2. So the 0 stays at 0, but the 180 goes to 360, and this 360 goes to 720. Now for the blue, 270 now goes up to 540. Or if you can think about it, the max is going to exist somewhere between 720 and 360. So it's going to be in the middle at 540. So what I can do is I can just graph that. Now, for the blue, you notice its minimum occurs halfway between 0 and 360. So that's going to be at 180. So I'm actually going to just put my dot here. And then what I'll do is I'll take my time and graph my curve. And this equation is actually y is equal to -4 sine of 0.5 x. Now, we have to go back to our original curve. Our curve now shifts down by -1. Shifting down by -1 means it's going to be this color here. Let's go and make it a new color. Let's make it purple. So our new color is going to be purple. And all we're going to do is we're going to move the green graph up, no, down actually 1 unit. So that is what this really represents. The vertical shift is down 1. Now we're going to go and graph the final equation. So we're going to write y is equal to -4 sine of 0.5 x and then subtract 1. Now all we're going to do is we're going to graph that final graph. Which will start at 1. And there's our final graph. So, going through all the steps, we have to, first of all, one, start with our original graph, y is equal to sine x. The next graph, we go and take a look at the amplitude. We stretch it vertically as much as we can. That's what the A value does. Then once we apply the -4 to the graph, it flips the graph. The -4 0.5 sine x is going to basically take the graph and stretch the curve horizontally. And do that by calculating the period as evidenced up here. You figure out what the new period is, then just move all the regular points and translate those points from the blue graph to the new green graph. The final thing is to apply vertical shift. And there we have it, a sample graph. Now, we'll take a look at another graph and see what happens. So this graph is y is equal to 2 cosine 2x minus 90 plus 3. We're going to actually take some serious looks at this. I'm going to actually go and take a look at the amplitude and all this other stuff that we used to look at before. The amplitude, A, is 2. The period is equal to 360, and then we use this 2 and divide by it. So the new period of my graph is going to be 180, 180. Now, this part here goes and tells us that we have a left, a horizontal shift or phase shift is going to be right 90 degrees. This portion here will tell us that our vertical shift is equal to 3. So, when we do these graphs, we will always start by graphing the basic curve. And we start with graphing y equals cosec. And I'll graph that in black. So we've got y is equal to cosine of x. So in order to graph that, cosine goes from 360 and from 0 to 360, and it starts at 1. So we're going to go and graph the starting point and the end point of 360. We know that exactly halfway through this period, it goes down to -1, which means if I go exactly halfway between 360 and 180, that's where I get my 0, because it's eventually going to have to go up. It goes from the bottom to the top. And we start from the bottom at 180, and it's going to have to go up to 90 in order to make that nice, smooth curve, which is going to look something like this. And there we have y is equal to cosine x. The next thing what we have to do, just like before, is we look at the amplitude. The amplitude is identified by the 2 sitting in front of our graph. So the amplitude goes and stretches our graph by a factor of 2. So we multiply all of our y points by 2. So 1 goes to 2, 0 still goes to 0, and -1 goes down to -2. 270 still goes to 0, and 360 at -1 goes to +2. And all we're going to do is we're going to graph said points. And there we have our first graph. And this is going to be y is equal to 2 cosine of x. So now we're going to go and add the 2 to our equation. We're going to use the blue to represent that. So we're going to add the 2 that's inside the bracket. So now our equation is y is equal to 2 cosine of 2x. Now, based on that, we figured out that the period of our graph is 180. All of the y values stay the same, but all of the x values change. Now, our graph still starts at 0, but it starts at position 2. And it only goes for a total of 180 degrees. So it also ends at 180 degrees at a height of 2. Its minimum is also going to be the negative 2, but it's going to end at 90 because that's exactly halfway between the first and the last point of our graph. The next part, we can go and label these points here. This first point between 0 and 90 is 45, and the second point is 135. So now that we have our new graph, we can graph our new blue curve, which looks something like this. Okay? So now, that is our basic graph for y is equal to 2 cosine of 2x. Now, we have to add the phase shift. So I'm going to make the phase shift a red graph. So we're going to go and go y is equal to 2 cosine of 2 x minus 90. So x minus 90 means we said it moved the graph right 90. So what we're going to do is we're going to take a moment and we're going to move that graph 90 degrees to the right. And shifting this graph to right 90 is going to look something similar to this. We actually just move it over. I guess I got to undo that. Undo. And now we're going to take our red graph, we're going to move it to the right 90 degrees. So all we've done is shift all the points over to the right 90. So now, the last thing that we have to do is we have to look at our graph and make sure that, oh, it's being shifted up exactly 3 units. So we're going to go and use a different color pen, and we're going to finish off with our purple again. So we're going to add 3 units, and that's what our last translation means. 2 cosine of 2x minus 90 plus 3. So this last purple graph is going to have to be shifted up 3 units. And I'll do that right now. So imagine we've got our red, and all I'm going to do is after I have copied, pasted my picture, I'm going to change my picture. And I'll show you what actually happens. So when we graph this last point, our original graph is going to look like it starts here, and all we've done is taken all of the points, all the points that we start and end with, and all we've done is just move them up exactly 3 units. Right about there. And there we have our final graph. Good luck. Hope you do better on these things. You should have taken the time to study the notes that I gave you. Good luck, guys. Test on Tuesday.